Hey guys, welcome to another vectors lesson. Today we're going to tackle a word problem that is quite often seen in exams for vectors and all of that. So hopefully doing this problem will help you guys do better on your tests and so on. So let's try this. John walks 20 kilometers in the direction of bearing 30 degrees true, then walks 15 kilometers in the direction of bearing 160 degrees true. Find the resulting position of John with respect to his starting point. So what we want to do is firstly take note of the fact that there's two bearings in this question. The first bearing, two vectors in this question, and the first vector is where he walks 20 kilometers in the direction of 30 degrees true. So we're going to draw that bearing to start off. Okay, so let's draw a bearing by drawing the axis, the grid. Okay, so we have the x-axis, or actually let's make this simple. This is the north, and we have 30 degrees from the north, so let's just draw a line, and this is 30 degrees. Okay, and let's call this first section of his walk bearing A. Okay, and what we want to do is, in order to complete this problem, we need the horizontal and vertical component of bearing A. Okay, so in other words, we want to write bearing A in terms of xi plus yj, and we need to know what x is and what y is. So let's change this axis to the Cartesian plane. So we have the x-axis here and we have the y-axis here, and we're going to draw a vertical line down to the x-axis from the head of the bearing. So we have a right angle triangle. Now we need to know what theta is, because theta is the angle that the bearing makes with the x-axis. So let's isolate this triangle. So we have the angle here is 90 minus 30, right? Because this angle here is 90 degrees. So 90 minus 30 is 60 degrees. Okay, and bearing A is 20 kilometers. And we need to know the vertical component and the horizontal component. Okay, so using trigonometry, we are going to use sine theta equals opposite over hypotenuse. Sine 60 equals, and this is the opposite, this is the adjacent, this is the hypotenuse. Okay, so y over 20, so y equals 20 times sine 60, which equals 17.32. and you can see here it's with Microsoft Mathematics, it actually gives you the output in surd form as well. But we're just going to use the decimal number today. So 17.32 is the vertical component. Kilometers. Okay, and let's now find x. So cos theta equals a over h. Cos 60 equals x over 20, so x equals 20 cos 60, and let's use the calculator again. So 20 times cos 60, and the answer is 10. So I'm going to write 10 kilometers here. So I can rewrite bearing A as 10I plus 17.32J. Okay, so that's bearing A rewritten as position vector. And now we want the second bearing. So he then walks 15 kilometers in the direction of bearing 160 degrees true. So let's get that second bearing converted into a position vector. So we have 160 degrees. So here we have the north, and we got 90 degrees, 180 degrees. So 160 degrees would be somewhere along here, and this angle would be 20, right? Because 180 minus 20 is 160. Now we just need to find this angle, and this angle would obviously be 90 degrees for this whole quadrant. So 90 minus 20 is 70 degrees. Okay, so this is vector B, which is 15 kilometers long. So this is vector B, and we're gonna draw a vertical line down to the x-axis, and this is our right angle triangle, and this is 15 kilometers, vector B. Okay, so let's isolate that triangle, and we have 15 here. We got an angle of 70, and we're looking for y, and we're looking for x. Okay, now notice that while x is still in the positive direction, y is now in the negative direction. So therefore, once we find y, and we're going to put it in the position position vector, we have to write minus something j. Okay, so let's just find x and y. So sine theta equals opposite over hypotenuse. So that's opposite, hypotenuse, adjacent. Sine 70 equals y over 15. Y equals 15 sine 70, which is equal to 15 times sine 70. And the answer is 14.09. So by the way, this program is called Microsoft Mathematics, which is a free program for calculating. So get that if you want a free calculator. So we got 14.09. And now let's do cos theta equals a over h. Cos 70 equals x over 15. X equals 15 cos 70. X equals, so 15 times cos 70. And the answer is 5.13. So x is 5.13. And then the bearing B, which is the second part of his walk, is 5.13 I minus 14.09 J. Right, because y is going downwards from the horizontal. So this is the x-axis, this is the y-axis. Right, so if you imagine this is the point from at the origin, we move to the right 5.13 units, and then we move downwards 14.09 units. Okay, so this is the bearing, this is the vector B position vector. So if we add the two vectors together, we can find the resulting position. So when we go vector A plus vector B, and all you have to do when you're adding the vectors is you add the numbers in front of I. So it's 15.13I, and then you add the numbers in front of J, and then put it in front of J. So 17.32 minus 14.09. So 17.32 minus 14.09 is 3.23. So 3.23 J. So that is the resulting vector. Okay, and once you have done that, okay, then all you have to do is we want his resulting position with respect to the starting point. Okay, so then what we need to do is again draw this bearing. So we have the Cartesian plane, and we're starting from the middle, and we move to the right 15.13 units. So this is 0. We move to the right 15.13, and then we move up 3.23. So this is our vector. This is our resulting vector. Okay, so then what we want to do is find the magnitude in the direction of this vector. Okay, so the magnitude of A plus B, the magnitude is the square root of the two numbers, the x and the y components. So 15.13 squared plus 3.23 squared, and then the square root of that is, let's use the calculator again. So enter into the calculator the square root of 15.13 squared plus 3.23 squared, and the answer is 15.47. Okay, and then that's the magnitude. So it's in kilometers, and we have rounded it to 2 dp. And then let's find the direction, which is this angle here. So we have a right angle triangle, and we have 3.23. We want this angle, and we got 15.13, so that's opposite adjacent. Tan theta equals opposite over adjacent. Tan theta equals 3.23 over 15.13. So theta equals inverse tan and then put that in your calculator. So inverse tan so if you're working in Microsoft Mathematics, you have to find inverse tan in this calculator on the left. So inverse tan 3.23 over 15.13, and the answer is 12.05 degrees. Now what you need to make sure is that we're going to change this angle to a bearing. So even though theta is 12.05, we need to know what this angle is, because a bearing is from the north. So we want to find this angle by going 90 minus 12.05, which is 90 minus 12.05, which is 77.95 degrees. Okay, so the final answer is, okay, John's final position is 15.47 kilometers at a direction of 77.95 degrees true from his starting point. Okay, thanks for watching, guys. See you next time.